Number 1. List the elements of each of the following sets. P is prime numbers less than 20. What's the first prime number? 2, 3, 5, 7, 11, 13, 17, 19. And I stop there because it says less than 20. Plus 20 is not prime. F are factors of 20. So what multiplies give me 20? 1 and 20. What else? 2 and 10 and 4 and 5. W equals prime numbers between 24 and 28. So 25, is that prime? No, because 125, 5, 5. 26, is that prime? No, because the only even prime is actually 2, right? 27, is it prime?
Yes. No.
No, because 9 times 3. 9 times 3 is 27. So, what prime numbers are there between 24 and 28?
27.
Empty set. 27 is not prime. 9 times 3 is 27. I literally just said that. Okay. 2, we have to do 2a. Now, a lot of people will just say a is are multiples of 7 less than 30 usually. But you have to use more. If you just say multiples of 7, that's for sure not enough. Because if I just told multiples of 7, I'd go 7, 14, 21, 28, 35, 42, and I keep going, right? But I could also go -7, -14. Those are still multiples in some ways. So what we're going to do is we should say natural numbers less than what? Natural numbers less than what? We could say 30, or we could say 29. We could say less than or equal to 28, right? I'm just lazy and don't want to write equal to. So natural numbers less than 29 that are multiples of 7. Instead of saying that are multiples of 7, what else could I have said? That's the D.
Divisible.
Yes, divisible by 7 would work too. Okay? Let me go to this one. Tony is an owner of a sandwich shop. Customers may put any of the following toppings on their sandwiches: lettuce, tomatoes, cheese, pickles, onions, olives, roast beef, and salami. Let T equal the sandwich toppings available at Tony's shop. Determine the value of N of T. What does N of T mean? What does N of T mean? What does little n mean? Yeah. The number of elements in
Tomato.
the number of, I think you probably even heard me slapping my forehead on that one. The number of elements in T, which is Tony's sandwich shop, right? Not in tomato. Number of elements in Tony's shop. Or we could say the number of sandwich toppings available at Tony's shop. That would work too. And what is N of T? What does it equal? 8. List the elements of M, the meat toppings available at Tony's shop. So M equals what? What are they?
Roast beef and salami.
Roast beef and salami.
Yummy.
I wouldn't answer 2 because that would be N of M, right? N of M would be 2. But M, you have to just list what they are. So they're roast beef and salami. Those are my 2 elements. Then it says, explain why M is a subset of T. Why is M a subset of T? And a subset means everything in M is in T. Remember that? So why is M a subset of T? Because roast beef and salami, the two meats, are found in all the toppings, right? Are elements of the toppings. Okay. C says, determine whether each of the following is a subset of T. Explain your reasoning. So are olives, pickles, and tomatoes a subset of T? Are they all found in T? Yes. Yes, they are a subset. And it says, explain your reasoning. So if all you wrote is yes, they are a subset, you wouldn't get full marks. Yes, they are a subset because they are all toppings in T. All toppings are all elements in T. In set T. It's a set. What about lettuce, cheese, bacon, and salami?
No.
No, why?
Bacon.
Right. So not a subset of T because bacon is not an element in T. Is the empty set a subset of T? The empty set? We went over this yesterday. Yes. The empty set is a subset of everything because when you have nothing in it, nothing is located in T because it always is. So, yes, the empty set, which can be represented by squiggly brackets, 0 to slash. So the empty set is a subset of all sets. Including T. Is T a subset of T? Is everything in T? Not a trick question. Yes. Every subset is a subset. Every set, is a subset of itself. Because in order to be a subset, everything in the one set has to be included in the other set, right? So T for sure is going to be a subset of T. Because everything in T is in set T. For 4, I just wanted you to do these. So for 4, it says A, B, C, and D are sets. A equals the set Q. What's in the set of A, is the element Q. What's in the set B is the elements P, Q, and R. What's in the set C are the elements R, S. What's in the set D are the elements P, Q, S. Which of the following statements are true? What is this E with a slash, this weird C with a slash, it looks like an E mean? An element of. Is Q an element of A? Anything in these brackets are elements, right? Is Q an element of A? Yeah. Anything that's listed in those squiggly brackets are elements. So this is true. C, the set Q is an element of A. Is the set Q an element of A? No, up here it says A equals set Q. So how could set Q be an element of A? Set Q equals A. So this is false. Without the squiggly brackets, Q is an element of A. That is true. But the set Q is not an element of A. It's a set. But it equals. Q is not an element of C. Is that true? Is Q and C? Nope. So Q is not an element of C. C only has R and S. So this is true. A is a subset of B. Is A a subset of B? Is everything in A found in B? A has Q. Does B have Q?
Yes.
Yes. So this is true. Set A is an element of D. No, the only elements in D are P, Q, and S, right? So that's false. D is a subset of D.
Yeah.
Yep. Because any set is a subset of itself. Number 5, if the universal set is 1, 2, 3, 4, 5, 6, and A equals 1, 2, 4, and B equals 1, 3, 5, list the elements in not A and not B. Or the complement of A, complement of B. So the complement of A is everything that's not in A, but it's in the universal set. So we can't state complements unless we actually have a universal set, correct? Or else who knows what the other numbers could be. So A is 1, 2, 4. So the complement of A would be 3, 5, 6. B is 1, 3, 5. So what's the complement of B? 2, 4, 6. Then next page. Then we did number 7. Number 7 says, if A is red, green, blue, if the set of A, contains the elements red, green, blue, and the complement of A contains the elements black, white, list the elements in the universal set. What are they going to be? Yeah.
Red, green, black.
Right, because they're opposites of each other, right? A and the complement of A should include everything from the universal set. The universal set includes red, green, blue, black, white. We're going to use this homework after we learn some new lessons, so don't make this go far away. So I want you to go to your notes. So if you look at your formula sheet over there, on the bottom right-hand side, if you're getting you a formula sheet, trying to make them covered so that they, yeah, they're pretty. Thank you. So on the formula sheet, it tells you that intersection is represented by this symbol, which is an upside down U. And it says union is represented by this symbol, which is just a plain old U. And that's why the universal set needed to be U with the horseshoe tops, right? Because it's totally different than union. Because that is union. Now, if I just talk about this class, please raise your hand if you are in social currently. So many of you. Wow. And then please raise your hand if you are in English. Well, that was a disappointment. Okay. Now raise your hand if you're in social and English. There's no one. Why?
Nobody's taking this one.
No one's taking social and English, so they have to be in what in order to be counted? They have to be in both courses, right? Okay, let's go back over this. If you're in social, raise your hand. Oh, much prouder this time. And if you're in English, raise your hand. Okay. Now, if you're in social or English, raise your hand. What did you all do? You raised your hands if you were in social or you were in English. So or made more people raise their hands, right? Because it didn't matter if you were both. It just mattered that you were in one of them for sure. If you were in both, would you still have raised your hand if you were in social or English? Yeah, because you're in social or English. You just happen to also be in social and English, but that doesn't matter. If you were in one of them, you'd raise your hands. Okay? Keep that in mind. So, and you have to be in both, or you can be in either or you could be in both. That's totally fine too. But the moment that, like, Jax was in social, you were counted. If you were in English too, it wouldn't matter. You still counted once, right? I'd list you once. Okay? So let's go through this. So we will use examples on the previous page. So this is from before. We have E was 0, 2, 4, 6, and 8. L was the set 0, 1, 2, 3, 4, 5, 6. And O was the set 1, 3, 5. So we're going to go over intersection of sets. Remember, intersection of sets gets you the little symbol like this. Just giving up. Okay. I think you just popped, your pencil fell and you're just leaving it. Grab a new one. Get it later, you know? Okay. So, when you have this symbol, intersection means and this is the easiest way to remember it. I can write the word and. Boom. Mind-boggling. Life lessons right there. So if the symbol, you could write a rounded and, it means and. Okay? So intersection is and. So the intersection of set A and set B is called A and B. It is denoted by A and the upside down U, B. It is a set of elements that are members of both sets A and B. So here it says, write the intersection. Intersection is this symbol. This symbol can be written into an and, so it means and, right? The intersection of E and L. So I'm going to make that, write that out. E and L. They could write it like this too. They could go E intersection L. Right? Or they could go E intersection, I don't know what I was doing there, L. Right? Both of those mean the same thing. They both mean E and L. So we only raised our hands, which was none of you, if you were in social and English. It kind of backfired. I was just guessing and hoping one of you were in English and you weren't. So then you guys, social and English actually in this class is the empty set. Right? There's no one in social and English, so it would be the empty set. So here, what are the elements that are in E and L? 0. Carry on. 2, 4, 6. That's it. The rest are in E or L, right? But not E and L. Then we do union of sets. How do I know it's not and? Well, union of sets is a U. How do I know it's not and? Because I write and it looks stupid. That's how I know it's not and. Ah, see? Easy. That looks dumb. So it's not and, it's actually or. Okay? Union is for or. Intersection is for and. So the union of set A and set B is called A or B, and it is denoted A, U, B. It is the set of elements that are members of either set A or set B or both. It includes anything, right? So I said if you raise your hand for social or you raise your hand for English, I'd count you. And if you raise your hand for both, I'd still count you, but I only count you once. Okay? So here it says, use appropriate notation to write the union of set E or L. So I want E union L. So what's in A or L? A or L? Nothing, because there's no A. What's in E or L? 0. Do I write it twice? Nope, count it once. Even if it's in both, I still count it once. So 0, then what?
2,
1,
1,
2,
3,
3,
4,
4, 5,
6,
6.
7,
Not true. 8.
8.
Oh, I can put the red one. So if it was in either or, I would write it. Correct? This is a really easy concept. It's also one that you guys get wrong constantly. Okay? So, because you overthink it. Because it's so easy, you overthink it. With or, you guys will list all the elements that are in both, but then you won't list the ones that are doubled. Like if it's 0 and 0, you won't list it. It gets listed, remember? If it's in either or both, I list it with or. With and, I only list it if it's in both. Okay? So or, you often have more, right? And we only have these, or we have way more, don't we? Okay? The only time you won't have more is if the two sets are exactly the same. For and or, you'd have the exact same amount. That's the only way. Disjoint sets. Two sets are said to be disjoint if they have no elements in common. The intersection of two sets is the empty set. That's very important. The intersection of the two sets results in the empty set. So for example, when I did social and English unintentionally, I would have gotten the empty set, right? Because no one in this class is in social and English. So social and English is actually disjoint for this class because there's no one in both. So here I have 2, 3, 4, 5, 6, 7 are disjoint because they have no elements in common. Which two sets up here are disjoint? ELO, which two of them are disjoint? E and O. And we say it exactly how you did with the and. Because E and O have nothing in common, right? How can I write that in set notation? E and O equal what? The empty set, right? So they could say which of the two following sets are disjoint, and you'd say E and O. And if they said why, you could say because you can just show this: E and O equals the empty set. Therefore, there's nothing in common, right? So that's how you prove the empty set. You prove the empty set by doing the intersection of two elements, or two sets, not elements, it's sets. The intersection of two sets, and if they have nothing in common, they're disjoint. Okay? Let's look at example 3. Example 3 says, consider the sets A, B, C from class example 2, where U equals natural numbers less than 10. A equals the natural numbers less than 20. Natural numbers start at 1, right? You naturally count as a toddler. Natural numbers less than 20 that are divisible by 3. So they gave them to us even. 3, 6, 9, 12, 15, 18. Then B are the natural numbers less than 20 that are divisible by 5. 5, 10, 15. Why didn't I list 20? Because this is less than 20, not less than or equal to. If it said that, I would include 20, right? And then natural numbers less than 20 that are multiples of 6, 6, 12, 18. Okay, they're all listed. I want you guys to try this. Try A. List the elements. Okay, what's in A and B? 15. And this is an and because I can turn it into an and, right? This is not an and because that looks stupid. So it's a or. What's in A or B?
3, 5, 9, 10, 12, 15.
Why did we list the 15? It's in both. Go with it, you were right. Why did we list the 15? It's in both. Yeah, because it's or. It's still in A or in B. It also just happens to be in both as well. So I include it, but I just include it once, right? I'm making a point of that because people will not include it sometimes, which is wrong. So not A and B. So what I would do, instead of trying to do these in my head, I would go not A and I would write out the complement of A. So I have 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. So what's in not A and in B? Is 5 in both? Yeah. Is 10 in both? Yeah. Is 15 in both? Nope. So it's just 5 and 10. I didn't even look at the not A, like I didn't go through all those. I went through the shorter one because if it's 5, 10, and 15, if it's not those, right, it can't be in both. I just compare the shorter one. Okay, you're going to try B. I can call this B and C, or B intersection C, or B the symbol C, right? They all mean the same thing. It's and, because I can make it into a word and. So what's in B and C? The empty set. So what can we say about B and C? They are disjointed, yes. A or C. What's in A or in C?
3, 6, 9, 12, 13, 14.
15, he said. 18. What's in A and in C? 6 and 12?
6, 12, 18.
And 18. Okay, we're going to flip over. We're going to ignore the top question because it's a repeat. We're just going to go to C. So C is where they can get more complicated. So, just like bed mass rules, we have to do brackets first here. So we're going to do these ones first. So B or D. Okay? So, down here I'm going to do B or D. What's in B or in D? D is here, 2, 4, 6, 8, 10, 12, 14, 16, 18. B has 10, 5, 10, 15, I believe. So what's in B or D? 2, 4, 5, 6, 8, 10, 12, 14, 15, 16, 18. So we finish that, we do that off to the side, right? We do the bracket off to the side. And now we have to say, so A had what in it? 3, 6, 9, that one, I think. 18. B had, I just want to write them up here so we have them. 5, 10, 15. I don't remember what C was anymore.
6, 12, and 10.
Okay, multiples of 6. I'm not there. Okay. So I want what's in A and bud. What's in A and in bud? 6, not 9, 12, 15, and 18. Yeah. For number 2, which do I have to do first? A intersection B, correct? A and B, because it's the one in brackets. So what's in A and in B? 15? Now I want what's in A and B or D. So this is my A and B set. This is my D set. So I'm going to list everything that's in both, right? Because I have what in between them? A union or an or, right? So I'm going to get 2, 4, 6, 8, 10, 12, 14, 15, 16, 18. The last one is the most work. So I need what's in not A and not B. So I need what's in both of not of those. And then I have to do the not of that. So we're going to go not A and not B. So I have to do my not A first. I'm going to write it down here. Not A equals 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. Not B is a lot. 1, 2, 3, 4, not 6, 7, 8, 9, 10, 11, 12, 13, 14, not 15, 16, 17, 18, 19, etc. Right? So the complement of A is just what's not in A. The complement of B is just not what's not in B, right? Now I want what's not in both of them. So I look at not A, I look at not B, and I list the ones that are in both, right? Because this is the and symbol. So what's in both of these? 1 looks like it's in both, right? 1, 2, 4, 7, 11, 13, 19. There's a little 19 down here. I made it go to the next line because it has space. So that's what's in not A and not B, right? That's this. But I actually want what's not in those. So the answer is everything but that. Yep. So it's going to be 3, 1, 2 are out, 3, 4's out, 5, 6, 7's out, 8's out, 9, 10, 11's out, 12, 15, 17, 18. Okay? Now please pay attention. This is your workbook assignment pages. You have almost all of them. I have to hand out one more page. That's the one that I think is from 9 to 14. So I'm going to come around and hand out another page to you to put your mask on. I'm giving you enough time in class to finish this. So this should not be homework. This should be in class done, go over tomorrow work. Okay? Not homework.